Okay, in this lesson we will be looking at direct variation. Direct variation is when you're looking at how two quantities change in relationship to another. And with direct variation, as one variable changes, the other variable changes in the same way. So they either both increase or they both decrease. So here's an example. The price of a home will increase if the square footage increases. Okay, so they both move the same direction, and the same is true the other way. If the square footage of a house is smaller, the price of the house is generally smaller. Okay? Here's another one. If a person has a bigger shoe size, that means they have a bigger foot. Okay? Or I probably should have said that the other way around. But the bigger the foot you have, the bigger the shoe size you have. And the opposite is true. The smaller the foot, the smaller the shoe size. Okay? Both things move in the same direction. As one gets bigger, the other gets bigger, or as one gets smaller, the other gets smaller. Okay, but they move in the same direction. The basic equation for direct variation is y equals kx, and your job is to put in some variables and to figure out what this k is. And this k is like k stands for constant. It's a number that you can multiply one variable by to get the other variable. Okay, so here's how this is going to look. You're going to start with this first sentence here. Y varies directly as x. We've got that. We're going to plug in y equals 12 and x equals negative 3, and we're going to stop right there and solve for k. So when I plug that in, I have 12 equals, I don't know what my k value is, but I know that my x is negative 3. So then I divide by negative 3, and of course k equals negative 4. Okay, so that's your constant. Now, you have used this information right here, and now I'm asking you to find, well, when x is 16 with that same constant of negative 4, if x is 16, then can I predict my y? And of course you can. So you're going back to this equation again. I want to find a new y. I just figured out that my k was negative 4, and I have a new x value of 16. So negative 4 times 16, of course, gives you negative 64. Okay? And here's another one. If y varies directly as x, then y equals negative 15. Then when x equals 5, then find y when x equals 3. Same thing. The first thing you're going to do is plug in those first pieces of information. So negative 15 equals k times 5. So k equals negative 3. And then I will go back to y equals kx here. I've used this. Okay. I will put in my new y value, which I don't know. I'm trying to find out. You might have to find a new x value, by the way. You're not always going to find y. You might have to find a new x value, but in this case, I'm finding y. My k is negative 3, and my x is 3, so then y is negative 9. Okay? Just so you know, you might come up with situations where it'll say this. It might say, I'm going to make this sentence up and write it so that you can understand it, make sure you're okay. It might say something like this. R varies directly as the square of t. And if that's the case, this is what your sentence would look, or your equation would look like. R equals k. Directly means the other quantity has to be multiplied next to that k. And then the square of t, of course, would be written as t squared. So that's what your sentence or your equation would look like if that was the information you were given.